Okay, this problem says factor. That's all it tells us to do is factor. So I have some steps up here that we should do when we're asked to factor. The first one is look for something in common. If you see anything that's in common with any of the terms, we can factor it out. So in this problem I only have two terms to look at. I have the 1080s cubed and I have the 5. But I noticed that 5 can go into 1080 and 5 can go into itself. So that is my very first step, is to factor out that 5. When I divide 5 out of 1080, I am going to get, let's see, 216. So I have a 216 s cubed plus 1. I call this my leftovers. Okay, the leftovers are 216 s cubed plus 1. Within the leftovers, we like to look at them to see if they can factor even further. And so that's our step 2. Look at the number of terms we have left over. If there are two terms, like we have here, we have 216s cubed and we have a 1. So that is two terms. We ask ourselves a few questions. First of all, is it the difference of squares? That means difference means subtraction. Squares means something times itself. So first of all, I don't have a subtraction, and 216, I'm not sure if that's something times itself, we'll say, but I don't have a subtraction, so I know it can't be the difference of squares. If it would have been the difference of squares, we could factor that into conjugate pairs, but it's not. So let's go to the next question. Is it the sum or the difference of cubes? Well, we do have a sum here. I need to see if this is perfect cubes then. I see an s cubed, so that gives me a clue that it is. The number 1 is always a perfect cube, it's a perfect square, because it's 1 times itself, however many times you want it to be. 1 times 1 times 1. So 1 is a perfect cube. And 216, let's check to see if that's a perfect cube. In my calculator, I'm going to type 216 divided by 6. That gives me 36. And 36 is a perfect square, so that means it came from 2 more 6's. So 216 is in fact 6 cubed. So I have the 6, I have the s, both of them involved in there. If we had 6s times another 6s times another 6s, I would get my 216s cubed, which is why I know that it is a perfect cube. So I rewrote it like that just so I could see the 6s being cubed and the 1 being cubed. If we're going to factor a sum of cubes, we have to know a formula. So I put this up here as well. You might have seen that. The formula for the sum of cubes and the difference of cubes they look very much alike. And because they look so much alike, other than their signs, notice their signs here are the only thing that's different with the two formulas. Students often get them confused with each other, or in the middle of a test, they might forget which formula, which sign goes with which. So I have this acronym here, SOAP. And it stands for same, opposite, always positive. That corresponds to the signs that are in our formula. So if we're doing the sum of cubes, our first sign within our factored form, within this parenthesis here, is going to be the same as that. It's going to be a plus. Our second sign is going to be the opposite. The O stands for opposite. The opposite as the plus. It would be a minus. And the last sign, AP, it's always positive. So beyond that, it's kind of your job just to memorize the formula. So we have the A, the B, the A squared, the AB, and the B squared. That part is up to you to memorize. This little SOAP acronym will help you get the signs in place. So I'm going to use this formula because I have the sum here, I have the addition of 2 cubes, 2 factors that are being cubed. So get the 5 out there. Don't forget we've factored the 5 out. So I'm going to go down to 2 parentheses here. I'm going to put my signs in first. I like putting my signs in first. So my first thing I'm going to do is put a plus sign here because it's the same as what I'm trying to factor, so it's the plus. The next sign is the opposite, so it's going to give me a minus. And the last sign is AP, always positive. So I have my signs in place there. Now I need to put in my other parts of the formula, which is the A, the B, the A squared, the AB, and the B squared. That A is whatever is being cubed. So A is not 216s. A is 6s for our formula. whatever is being cubed, whatever is being multiplied by itself 3 times to become whatever you have here, 216s cubed. So 6s is our a, so I'm going to put a 6s here. Our b is whatever is being cubed second, so that is the 1, because the 1 is being cubed, so I put the 1 here. So I have the 6s and the 1. Next I'm going to do a squared from the formula a squared. Well, a is 6s, so 6s squared needs to be 6s times itself. I can't write it as 6s squared like that. That is not right. I have to square the 6 and the s, so I have to put a parenthesis around that, and then I would simplify it. I'll do that in the step below it. So this would be 36. 36. Because we squared the 6 as well as the s. 36 s squared. Inside of our second spot we have a times b. So if a is 6s and b is 1, then I take the 6s and times it with the 1, which will be just minus 6s. And then the last spot here we have our b squared. Well, b is 1, so we need to square that. 1 squared, which turns out to be just 1 in this case. So again, this is a 36. Hopefully you can see that. This would be my final factored form for the sum of cubes.